Is this working? I don't know. uh, Twitch. Oh, we dropped a lot of frames. Okay. Oh, we dropped a lot of frames. I guess this is streaming. Okay, so I'm gonna close all this stuff, and I'm gonna open up my Visual Studio project. Is this really working? Amazing. Well, okay. So I'm gonna spend some time, maybe 20 minutes or something, I mean, this is my first stream, so I just want to make sure everything works. But I'm also gonna fix up this X and A game, Get Rich or Die Gaming. Basically, the code is a total mess, and I need to change a lot of things, and we're gonna do that. So I'm gonna set a timer for 20 minutes first, and then we'll start coding. So we're just gonna be coding. This is just a big refactor project. In X and A, the big thing is your game1 object. So you make an object that extends from an X and A game class, and by default it's called game1. I think a lot of people like to rename this to like Get Rich or Die Gaming or something that makes a bit more sense than game1. But by default it's game1. And when I did this project in 2010, I had no idea what I was doing. I didn't know anything about C#. I didn't know anything about object-oriented programming. And so I didn't really mess with too much. I just kind of got everything working, got everything compiling, and once I did that, I moved on to the next thing. It's not a bad way to do stuff sometimes, but you end up with some really ugly code. Okay, so let's just close all the other stuff and then build it. I'm not sure if I've got the latest code actually. That doesn't matter. We'll open up a SmartGit and see if we've got it or not. Okay, so this is the game. Here's a control screen. This control screen is actually just a PNG file, which is pretty bad because really it's just text, right? So I don't know how many characters that is. It's probably like 300. And 300 characters is about 300 times 8 bytes, which is 2,400 bytes. But as a PNG file, this is a 1280 by 720 PNG file. Actually, it's a bigger PNG file than that. But basically, we're just wasting a lot of memory by having that as a PNG file instead of text. So that's one of the things I want to do. I want to get that file, which is here, and turn it into text instead. So just redo that game state in text instead of doing it in PNG, which is quite easy to do. But it's just one of the many things we need to do. This is actually, you might, like, the resolution of this game is 1280 by 720. but this image is 2048 by 1024, and the reason for that is to enable texture compression, you need to have widths and heights on your textures of a power of 2. I don't know why. It's just one of these graphics card things. And so what I do is I just extend it out. And I've done that with you know, the logo. This is also a 1024 by 1024 image, and basically everything is 1024 by 1024 because you get a lot of memory savings. So that's weird. There should be something there. Oh, okay, no. So when you output your content, it's quite small. So that XNB file for the control screen. Oh, okay, that's huge. That's weird. That must mean texture compression is not enabled. Yeah, okay, so that should be, that's turning texture compression on. That's what you do. You just change the setting somewhere. And so right now that was built, well, I don't know, it was built ages ago, but a few days ago, 2 days ago. So that's 8 megs right now, and if we build it again, you know, Visual Studio is going to detect that I made a change in the properties of this control file, and it knows that it needs to build out this XMB file again. Is it building? No. Okay. I pressed F5, but it didn't do anything. Yeah, so when we build that out again, it comes out much smaller. Factor of 8, in fact. So everything's quite small. But, you know, we can actually get that 8,000 kilobytes down to 1,000 kilobytes, but we can actually turn that 1,000 kilobytes into, you know, basically 0 kilobytes by using text instead. Okay, so controls works. New game, I don't think it works. Does it do anything? Does it crash? If I press enter, I don't think it's doing anything. Okay, so this game is made up of a bunch of different states. Each state has an update and a draw function. The draw function just says how to draw stuff. The update function tells it how to update, and basically it handles control input or AI input or whatever. There's no AI in this game, so it's basically just controls and time as well. So we start off in the logo state. Logo state's pretty simple. Just draws a logo and then fades out. And then once it's done fading out, it jumps into the. Once it's done fading out, or you press enter, it jumps into the main menu state. So the main menu state is pretty simple as well. It's a bit like this sort of stuff is not nice, but you know, we can't fix everything all at once. This is a refactor, and you know, I will fix it eventually. But actually, you know what? I might not. I might not fix it eventually. Yeah. I just want to get it better than it is right now. So if we're pointing to menu option 0, we jump into the cutscene state, and if we're in option menu 1, we jump into the control state. Cutscenes are made of cues. These are all the cues you can have: text, sound, music, graphics, and cues. Cue is just an abstract class. Centered text is something that's only really used for the credits. Animation is something that's very uncommonly used as well. Animated characters are massively uncommon as well. I think there's one animated character. But we made a whole object and a bunch of shitty code for it. Okay, so we should jump into the cutscene and see what's happening. So in the update, it just passes in the update to the cutscenes update, and the draw just does the same. So what happens in cutscene update? Nothing. So that's why nothing's happening. So what should happen? Cutscenes are basically just, they're kind of like videos. So as time goes on, different things happen. Our cues have fire at and remove at, times, and what we want to do is when cutscene loading. And now, oh, it's because of this thing. I hate this thing. I'm gonna turn it off. Visual Studio, turn off preview window. Maybe we can figure it out, but I mean, it's probably just fast if they look it up. Window. Let's not do that. Environment tabs and windows. Okay. Environment. There's no environment. Tools options. Environment. Tabs windows. No, do not allow that. Go away, preview. Great, we don't have previews anymore. Okay. So in our cutscene, we want to say we have two lists in the cutscene. We've got where are these lists? Where are these lists? Yeah, so we have an all scene objects, which is just basically all the cues in the scene, and currently displayed objects list, which is the objects that are currently displayed. And so we need to figure out what time it is, and we also need to figure out like how long the cutscene's been running for, and we also need to figure out what cues should be in the currently displayed objects. The logic's pretty simple. So we're going to need a timer value, and these cues, they store time as U-longs, unsigned longs, so basically unsigned 64-bit integers. So our timer should be a U-long as well, just that makes a bit of sense. So let's make a private double, no, U-long timer. And then we want to initialize that, public void initialize, timer equals 0. Okay. And then when we update, we are just going to increment the timer. So timer plus equals game time dot elapsed game time. So this is the amount of time since the last update. The update runs 60 times a second, or at least it tries to. So basically, it's the amount of time that's passed since the last update. So we get elapsed game time, and we get milliseconds and total milliseconds. No, we don't want milliseconds. We want total milliseconds. This difference between milliseconds and total milliseconds is actually very subtle. Well, first this is a double, so we actually need to convert that to a float. I mean, sorry, a U-long. So we'll just go U-long. There shouldn't be any problems with double going to a U-long. Actually, there could be, but you know what? It's not gonna happen. So total milliseconds. It's the amount of time. So basically, if 40 milliseconds pass, total milliseconds will return 40 milliseconds. There's also this looks like a pretty reasonable line of code. This one below, milliseconds. And what's the difference? It's pretty subtle. So if 40 milliseconds is passed, or 16 milliseconds is passed, or whatever. So let's say 40 milliseconds is passed. This value will be 40, and this value will also be 40. So this is the total amount of milliseconds, and this is the milliseconds component. And that means that if a day and 40 milliseconds has passed since the last update, which could happen. So it's a day and 40 milliseconds has passed. This one's going to return 40, whereas this one will return a day in milliseconds, whatever that is, plus 40. Better case would be 1 second and 20 milliseconds, 1 second and 40 milliseconds. This will return 1,040 milliseconds, whereas this one will just return 40, and it'll give you behavior you don't want. And it is possible that 1 second could have passed since the last update. You might have dropped frames or whatever. So you want to use total milliseconds. But if you don't, you might not even notice it. It's just one of those subtle little bugs. So in a way, is it even a bug? Not until it becomes a bug. Okay, so now we know how much time has passed since the cutscene has started, and we want to figure out which queues. So one, put queues that belong in currently. Figure out which queues belong. It's basically move queues into currently displayed objects. So all seen objects. The logic for this is pretty simple. I'm just going to write it out and then explain it. What's going on here? For each queue, we can do var actually, but this is the queue. Queue in all seen objects. If queue dot fire at greater than timer dot fire at timer dot greater than timer. So if the queue is fire at is greater, no. If timer is greater than queue dot fire at, then we want to add that queue. We want to add that queue into currently displayed objects that add queue. And all seen objects dot remove queue. So basically, if there's a queue that's supposed to appear in 2 seconds time, and if the time is greater than 2 seconds, we add it to currently display objects and remove it from all seen objects, which is basically moving it from one queue to the other, or one list to the other. But actually we can't do that because we're using a for each. It's just one of these things. You can't alter the container while you're iterating across it. I don't know why. So instead of that, we want to do a for int I. We don't do for loop. Equals 0 I less than all seen objects dot length. No, count I plus plus. Basic for loop. And then we want to, that's just for niceness, QQ equals all seen objects I. Okay, great. So now we have basically what we had before, without the nice syntax. Okay, so that will move all the queues from all seen objects onto currently displayed objects. We also want to get rid of the expired queue. Remove expired queues. And to do that, it's the same sort of thing, so I'm just going to copy this thing, but we're actually iterating across a different list. We're iterating across the currently displayed objects. Currently displayed objects. Is that right? And we are just going to remove it from currently displayed objects. And that's that. Yeah. So queues go, basically queues go into all seen objects and then they go out when they expire. The logic is wrong actually. The logic should be timer greater than queue dot remove at. Okay, that's better. Now if we run this, I don't think it's gonna crash, but you know, who knows. But it's not gonna draw anything. It's gonna do stuff, but we don't know what it's doing. So we can put in breakpoints here to see when our queues jump out. Yeah, I mean, this is actually not ideal. Breakpoints aren't the ideal thing. We'd rather do console messages. So how about just this console.log? No, console.writeLine. Yeah, okay. Added a queue to all seen objects. I like to call ASO. I mean, some people hate acronyms, and I get that, but that name's bad. All seen objects and currently displayed objects. Move the queue from CDO. Okay, new game, and stuff should be happening. Is it? Is stuff happening? I don't know. I don't know. Let's click on output. Yeah, okay, so stuff is happening. Yeah, a lot of stuff's happening. So it's going across the opening scene, and the opening scene has a lot of cues in it. So if we go into game1.cutscene loaders, this is an example of something that needs to be changed. But we'll do that on another episode. So cutscene 1, is this it? Yeah, so these are all the cues in cutscene 1. It's not as many as I thought, but it's still quite a lot. So this is like, I don't know, let's say 10, 20, 30, 35 cues. And they, this one comes in at 30 seconds, 30.2 seconds, 26 seconds, 34.5 seconds, all this stuff. And it goes away, this is the fire at time, this is the remove at time. Yeah. So we don't really know if that code's working properly or not, because we could, dive down deep and make sure it works by running a bunch of tests and making a bunch of assumptions and looking at the timers and stuff. But I'd much rather continue with it. And where were we anyway? We were in cutscene, right? Yeah. So let's draw something. Let's draw these cues that are in all scene objects. So the logic is quite simple. It's actually just for each cue in all scene objects, cue.draw. And we pass in a sprite badge, which is just like, you can imagine it as just a place where things are drawn. Okay, so that we'll call cue.draw, and cue.draw is a method that, where's cue.draw? Yeah, it's an abstract method that must be implemented by all these guys. But they haven't. They haven't implemented them yet, those bastards. So if we run it, I don't think anything's going to draw, because none of them have implemented their draw methods. Oh, that's the end of the show.